Okay. Right. So, okay. Actually, no, let me do this. Let me do this. So this is the solution set. Ne? I said to you, we find the solution set. Solution set, not solution set. I don't know why this is coming. So let us just take R1 and see if whether R1 is gonna. Okay. So I'll do it myself. Minus 1a. Okay, let me use it. Okay. It's going to be minus 1a plus 9a minus 3/4. Okay. And this gives me 2. So if I can multiply this by 2 by 2, 2 by 2 becomes negative 1a plus 9a minus 6a. Okay. So this becomes this plus that, this becomes 8. So negative 9 minus 1. Okay, comes 2/8, which is 1/4. It doesn't mean. It doesn't mean. But apparently that's the solution that they got here. And it's still like. So I don't know why they took such a terrible example, but this is that example, example 1. You can check it on the textbooks. Wow. Wow. Oh, how can they make such an example? This is a terrible. Oh, Jesus. Okay, let's take another example from the same textbook. If this one is terrible as well, we're leaving this textbook by not using it. Well, I mean, for this session, not for. This is a prescribed textbook, so I can't say anything about it. Yeah. Okay, so the next one, example 2. Oh, that one, the upper one, they said it's better with Gauss elimination. Oh. Let us do example 2. We are given x1 minus x2 plus 2x3 is equals to 1. Okay. And then we are given x1 minus 2x3 is equals to 0. 1/2 x1 minus 1/2 x2 plus 2x3 is equals to 1. And then we have minus 4x1 plus 3x2 minus 4x3 is equals to negative 3. Okay. So look at this thing, guys. Okay. What do you see here? How many unknowns do we have? How many unknowns do you have, guys? With the side note that unknowns are given by x1, x2, xn. These are what we call the unknowns. So how many unknowns do we have? Mike, please mute your thing there, man.
So I think we have 3 unknowns.
We have 3 unknowns. Thank you, Mr. Mike. Thank you, Mr. Mike. So we've got 3 unknowns, but you can check, we've got 4 equations, okay? It means that one of these equations is going to give us something of 0 is equals to 0. It's a must. If our equations are greater than our unknowns, one has to give us something of 0 is equals to 0. Okay. So for now, let us just wait what we have. Okay. So but you guys are not going to make it. Keep quiet. R1, R2, R3, and R4. Okay. So we're gonna do the same thing. We're gonna say R1 minus R2, okay. So what I usually do, I'm gonna give you how I do it. What I usually do is, if I'm going to solve something of this nature, I always make this one to be 0. After making this one to be 0, I make this one to be 0. After making this one to be 0, I make this one to be 0. So I'm gonna deal with those ones to be 0, 0, 0, and 2. Okay. So now this one is going to be problematic because if I do it step by step, it's going to be problematic. Okay, so I'm going to have to write down the number of. Now, if here we can have, let's say, R1 minus R2 gives me R2. Okay, let me write R1 here at the top. X1 minus X2 plus 2x3 is equal to 1. Okay, so our R2 is defined by what we're going to get here. And then let us say now at the same time, let us have 2 times R3 minus R1 should give me R3. Okay, so I'm going to say 2 times. But what if I say R2? 2 times R3 minus R1 should give me R3. Okay, 2 times R3 minus R1 should give me that. And then what do you think we should do for R4? R4 is a negative, so I can just multiply R1 by 4 and just add 2. So I'm going to have R4 plus 4 times R1. This should give me R4. Okay, so these are the definitions of the new row. Okay, the linear equation. So let me write it here such that it looks very easy. X1 minus X2 plus 2x3 is equal to. Okay, now if I say R2 minus R1, did I write R2 minus R1, so it's X1 minus X1, so it just gives me 0. And then I've got 0 minus that, it just gives me X2. Okay, so this is what I get. Okay, and then I've got negative 2x3 minus 2x3, it gives me minus 4x3. Okay, and then I've got 0 minus 1, which is just minus 1. Okay, so are you fine with that one, guys? Are you happy? Are you satisfied? If you're not, please do let me know such that we come up with that. Okay, and the next one, now we said you're multiplying R3 by 2. Okay, which means now our R3, if we multiply it by 2, our R3 will be defined as, I usually write it at the top, okay, but I can't write it here because this thing will, the colors will be X. So if I multiply this by 2, I get X1. If I multiply this by 2, I get X2. If I multiply this by 3, I get 4x3. And if I multiply this by 2, I get 2. Okay, so I said this minus that. So X1 minus X1 is 0, minus X2 plus X2 is 0. 4x minus 2x is 2x. So it's going to be 2x3, 2x3. And then 2 minus 1 is just 1. Okay, so do you see how I'm doing it, guys? I said X1 minus X1 because it's 2 times R3 minus R1. So it's 2 times this minus that. And then this minus that, this minus that, and then lastly, B2 minus B1. Okay, so let us do the last one. So the last one we said we are multiplying R1 by 4. So it becomes 4 X1 minus 4x2 plus 8x3 is equal to 4. Okay, so 4x3 is, 8x3 is equal to 4. So I said we're gonna add the 2. Okay, so it becomes minus 4x1 plus 4. Oh, this plus that, it becomes 0. It's 4x1 minus 4x1, and then 4x2 minus 4x2 plus this one becomes minus x2. So it becomes minus x2, and then I'm gonna add 8x3 plus minus 4x3, it becomes 4x3. And then I'm going to have negative 3 plus 4, which is just 1. Okay. You guys are very quiet. You being very quiet like this is not okay. But okay, it's fine. I guess it's okay. Oh, now look at something, guys. Look at our R3 and our R4. Do you see that these things are exactly the same? They're exactly the same, just having multiplying one of the two by. If I can multiply this by a negative, it's going to give me x2 minus 4x3 is equals to negative 1. Do you see that this and that are exactly the same? Okay, so what I'm going to do there is I'm going to define my R4 to be, let me define my R4 to be, oh, actually we have solved this thing. We are done actually, guys. Okay, so the next part is that I'm going to say, let R4 and I add it with R2, give me R4. Okay, if I add R2 and R4, I must get, now our R1 stays the same, minus x2 plus 2x3 is equals to 1. My x2 stays the same, minus 4x3 minus 1. My x3 stays the same. I mean, my R3 stays the same. And then my R4 is the one that is going to be affected because we're changing. So it's this minus that is 0, this minus that is 0, this minus that is 0. So it's 0 is equals to 0. As I said, this must be true. Okay. So now let us find our values. Okay. So our 2x3 is equals to 1, meaning that our x3 is equals to 1/2. Okay. Now let us find our x2. x2 minus 4 times 1/2, which is x3, is equals to negative 1. Okay. What is 4 times half? It's just 2, right? So it becomes x2 is equals to negative 1 plus 2, which is 1. Okay. So let us find our x1. So our x1 and our x2 is 1. So it becomes negative 1 plus 2 times 1/2 is equals to 1. So this is 0. So our x1 is equals to 1. Therefore, I said to you, we're going to have what? A solution set. A solution set is given by x1, x2, and x3. What is these things equals to? x1 is equals to 1, x2 is equals to negative 1, and x3 is equals to 1/2. Okay, so we're going to ask ourselves, is this meeting the requirements of being called a system of linear equations? Let's see. We need to check it. Okay, so can I wrap this thing off? Are you fine with this idea, guys? If you're not fine, please do let me know. I'm doing this because I feel like, yeah, it's going to help you when you're doing matrices, because you are going to be skipping a lot of stuff. Okay, going to be skipping a lot of stuff. So let us take this to equation 1. Okay, so our x1 is 1 minus our x2 is minus 1. Then our x3 is 1/2. Do you see that this one already gives us 1? Because this, where is it? Oh, hey, I should not get excited. Otherwise, I'll be in trouble. Okay, so we need to check it, right? Because I was getting excited, but I see that my excitement is not. Hey, my x2 is 1. I nearly made a terrible mistake. My God, nearly made a terrible mistake. Do you see that my x2 is 1? Is minus 1 plus 2 is 1. I nearly made a terrible mistake. So my x1 is 1, my x2 is 1, and then I have 2 times half. Oh yeah, that's 1. So this becomes 2 times 1/2, which is equals to 1. And this is equals to that. Okay. So if you are not satisfied, let us do it with the second equation. So then I have x1 is 1 minus 2 times 1/2. This should be 0. So it's 1 minus 1, which is 0. And this is equals to that. Okay. So let us check with the third one. But guys, me just checking here, I don't know. I feel like, because if you can check without even substituting 1/2 times 1 minus 1/2 times 1 plus 2 times 1/2, this already gives me 1, because this is, yeah, they are going to cancel 1. This is just 1, and 1 relates to it. So I don't need to do the fourth equation, because we can see that these ones So the first example, I don't know why I put it there. You can check. Right. Okay. So let us continue. Let us continue. Let me find another one. Okay. Let me build your confidence. And then after building your confidence, you can call it a day, because I don't want us to be doing a lot of things. Okay. Because I know you guys don't ask questions. Right? Let me see. Oh, there are a lot of examples actually. And in the next session, we're going to be having the Gauss-Jordan elimination. We'll be solving these things with Gauss-Jordan elimination and seeing if whether are they really what they say. And then and then in that session, we'll be starting with our matrices algebra, matrix algebra. Okay, so let me do example number 3. So we have x1 plus 2x2 plus x3 minus x4 is equals to 1. Okay, so I've got 3x2 minus x3 plus x4 is equals to -3. And now we've got x1 plus 2x3 minus 2x4 is equals to 6. Now it becomes interesting. Okay, so my first question to you is, how many unknowns do we have, guys? How many unknowns do we have?
We have 4 unknowns, 3 equations.
We've got 4 unknowns and 3 equations, okay? Now, when we have something like this, okay? When we've got something like this, thanks, my brother, ne? 4 unknowns, 3 equations, okay? Now, I want you to look at something. When you've got something like this, guys, make sure by the solutions that you're going to have here, they are all going to be with respect to the last unknown, x4 in this particular case, okay? If I had a1 x1 plus a2 x2 plus a3 x3 is equals to b1, okay? And then I have b1 x, no, I can't use b1. Jesus. I can use okay, let me use another variable, d1 x1 plus d2 x2 plus d3 x3. This is equals to b2. And then here I have e1 x1 plus e2 x2 plus e3 x3 is equals to b3. Okay, so if I've got something like this, oh no, let me do it like this. In fact, let me not have this e1 term. If I have something of this nature, then my solution will be with respect to x3, because x3 is the last unknown. So which means you're going to rewrite x1 and x2 with respect to x3, and you are going to see if whether can we solve that thing or not. Okay, it's a nice concept here. It's a nice concept. Okay, yeah. So let us try and solve it. Okay. So I don't need to write R1, R2, R3 anymore, okay? Because we now know that R1 represents equation 1, R2 represents equation 2 and stuff. So now we're going straight and solving this thing, okay? We're going straight and solving it. So what I'm going to do is, I'm going to say R1 minus R3, okay? And then at the same time, let me not do it at the same time. In the meantime, R1 minus R3 should give me R1 plus together. So I have x1 plus 2x2 plus x3 minus x4 is equals to 1. Okay, so we're going to have 3x2 minus x3 plus x4 is equals to -3. So I said this minus that. Okay, that becomes 0. 2x minus 0 is just 2x. 2x2. Okay, and then this minus that, it becomes minus x3, and then this minus that becomes plus x4 is equals to 1 minus 6 is minus 4. Okay, are we fine with that, guys? Is there any question? Yeah. But usually we don't like working with negatives. We usually can say like R3 minus R1. It's only in the same. The most important thing is that the solutions must be the same. Okay. It doesn't matter if you said R1 minus R3 or R3 minus R1. But yeah. Okay. So now let us continue. Let us see what's going to happen next. Okay, the only way for me to take out x2 is if I multiply this and add by their respective coefficients. Okay, so if I multiply this and that by their coefficient, the respective coefficients, I'm going to have 2 times R2 minus 3 times R3 should give me R3. Okay, so meaning that this one multiplied by 2 becomes 6x2 minus 2x3 plus 2x4 minus 6, or is equal to negative 6. Okay, and then this one becomes 6x2, and then we're going to have negative 3x3, and then we're going to have 3x4 minus, or is equal to negative 50, because 3 times 5 is 50. Okay, 3 times 5 is 50. If you don't see here, let me know. I will write it. Okay. So I said it must be 2 times R2 minus 3 times R3. This will give me R3. Okay. So what I'm going to have is x1 plus 2x2 plus x3 minus x4 is equal to 1. This is not affected as well. x2, because I'm trying to change x3. I mean R3 plus x4 is equal to negative. Now let us look at this one. 6, it goes out. Okay, so we're gonna have negative 2x3 minus 3x3, so it becomes x3. Okay, and then here we have got 2x4 minus minus 3x4, it becomes negative x4, which is equal to 6 minus 15. Or it's minus 6, ne? Yeah, it's minus 6 minus 15. So I must write it here. Negative 6 minus 15. So it becomes negative 6 plus 15. Okay. So negative 6 plus 15, that's 9. Okay. So that's 9. Okay. So this is what we get. This is what we get. So from here, how are we going to rewrite this thing? Okay. Since x1, x2, and x3 are the basic unknowns that we can get with 3 equations, then, as I said, you're going to rewrite this in terms of x4. Your solution will be written in terms of x4 plus x3 is equal to 1 plus x4 as we transpose this. Then this one becomes 3x2 minus x3 is equal to negative 3 minus x4. And then the last one becomes x3 is equal to 9 plus x4. Okay, so this is our x3. Then we can take this, put it here and find our x2. But we cannot just find our x2 because we have got unknown. Okay, we've got unknown. Okay, I'll show you what I'm talking about. I've got 3x2 minus x3 is just this, minus 9 minus 4 is equal to negative 3 minus x4. Okay. So the question is now, how am I going to solve? How am I going to solve for x2? Okay. So it is simple to find x2, guys. It is very simple to find x2. Okay. Let's look at this. You see that these things, they've got the very same, yeah, the very same sign. Okay. So if I bring this side, it becomes 0. So it becomes 3x2 is, oh, is there somebody speaking? Okay. Minus 9 is equal to minus 3. So 3x2 is equal to 6. Okay. So which means our x2 is equal to 2. Okay. So we just found that our x2 is equal to 2. But we still need to find x1. We still need to find x3. Okay. And we do not know what is x4. Okay. So we're just going to continue with that until. Okay. So let us try and find our x1. Okay. So our x1 is given by, okay, let me write it with this black one because this red one doesn't look like it's fine. X1 is x1 plus 2. Can you see here, guys? I'm sure you can see. Plus 2 times 2 plus x3. X3, we're going to substitute 9 plus 4x is equals to 1 plus 4x. Do you see that also here, these ones, they're going to give us 0, okay? So they're going to go out. So you're going to have x1 plus 4 plus 9 is equals to 1, okay? 4 plus 9 is 18. So x1 is equals to negative 12, okay? So in this particular case, we found our x1, we found our x2. Our x3 is given with respect to x4. Now, how can we find x3? Okay. Now, the way to find x3, x3 can only be written in terms of x4. So, which means from here, the only thing we can do is just have an assumption because we have got two unknowns in one equation. Okay. So we can just assume. So, this thing of assuming, guys, I really don't like it. Okay. But
So we cannot find x4.
In this case, we cannot find x4. How? Okay, do you have an idea on how we can try to approach x4?
Yeah, like I have an idea, but I don't know how to.
No, take it out, my guy. Let's hear. Let's hear. Don't worry, you are protected.
Let's just leave it like that. Let's just assume.
Yeah, but we can't assume as we can't just assume. Say, okay. So me, what I will do if I was in this situation, okay, I will write this as now the system of the solution set x1, x2, x3, and x4. Me, honestly speaking, I was never going to do anything to this, but we'll see what the textbook is saying. So our x1 is negative 12, right? Our x2 is 2. Our x3, I was going to write 9 plus x4. And then my x4 is just x4. There's nothing else I can do. Okay?
As I was like the first equation, that x1 plus x2 plus, we can find x because we have x1 and we have x2. We can find x4 on that first equation.
Oh yeah, we can also do that, my man. We can also do that. Let's see. Actually, let's do it, such that we are. Yeah, but me, I'll leave it like that. Me, I'm lazy. So I don't know. Maybe I would lose marks, but I don't know. So let us go back to the original equation, okay? So let me wrap this. My guy over here has this idea that we can bring it back here. Okay. So we got less than 10 minutes. Okay, less than 10 minutes. So my guy, let us try and solve this. Okay. After solving this one, we call it a day. Okay. Call it a day. And then next time we're gonna do matrices. We're gonna do the same thing, but this time with matrices. Okay. So we got x1, which is negative 12, plus 2 times x2, which is 2, plus x3, which is 9, plus x4. And then we've got our x4, which is the unknown, which is 1. Okay. Okay, my guy. Now, what we're going to have is negative 12 plus 4 plus 9 plus x to the x4 plus x4 is equals to 1. Okay. So all the numbers go to one side. 2x4 is equals to 1. This becomes positive. This becomes negative. So let me try and solve this one side. 9 plus 4 is 13. 13 minus 12 is 1. So we take this one that side, and we can see that our x4 is equals to 0. Okay. Then if our x4 is 0, it tells us that our x3 is equals to 9. Then to rewrite this in a new way, we can have this as negative 12, 2, 9, and 0. So I don't know. We'll see what the textbook is saying. Maybe it's not true. We don't know. This textbook. Okay. So the textbook says that, they actually found negative 12, 2, 9, 0. Okay, they found this one. But they assume. Because they said that, note that if we have, for example, that x is equals to 0, this is an assumption. I don't know why they're doing that, but it's fine. Okay. So you see that they assumed here, but you see with what I did here, I was going to get the solution set as this one. So this is the solution set, meaning that this is the solution set. This is a set. Okay, it's fine. So this is the solution set. And then this is the fourth triplet. Okay, meaning that this is C1, this is C2, this is C3, and this is C4. And is this thing true? It must be true, because if we take this thing and substitute it here, okay, we should get a value of 1. Let us take negative 12 plus 2 times 2 plus 9 minus 0. So I don't write 0. So this is what? Negative 12 plus 4 plus 9 is 13, which is equals to 1. And that is true. Okay, so we found our 4 triplet and then the solution set. But I don't like how they found it in the textbook. Okay, and my guy, the way you said we should do it works out pretty well, so you can use that one. Okay, yeah. So guys, do you have any question? If you do not have any questions, then I can take the register and just has ended. Any questions?
No questions.
Okay, let's take the register and end the session. Thank you very much, guys, for attending. Have a lovely day and take care of yourselves. Thank you.